Galvanization, or galvanization, is the process of applying a protective zinc coating to steel or iron to prevent rusting. The most common method is hot-dip galvanizing, in which parts are submerged in a bath of molten zinc. Galvanizing protects in three ways. It forms a coating of zinc which, when intact, prevents corrosive substances from reaching the underlying steel or iron. The zinc serves as a sacrificial anode so that even if the coating is scratched, the exposed steel will still be protected by the remaining zinc. The zinc protects its base metal by corroding before iron. For better results, application of chromates over zinc is also seen as an industrial trend. Etymology. The earliest known example of galvanizing of iron, encountered by Europeans, is found on 17th-century Indian armor in the Royal Armouries Museum collection. It was named in English via French from the name of Italian scientist Luigi Galvani. Originally, galvanizing was the administration of electric shocks, in the 19th century also termed Faradism. This sense is the origin of the meaning of the metaphorical use of the verb galvanize, as in galvanize into action, or to stimulate a complacent person or group to take action. The term galvanizing has largely come to be associated with zinc coatings, to the exclusion of other metals. Galvanic paint, a precursor to hot-dip galvanizing, was patented by Stanislas Sorel of Paris in December 1837. Methods. Hot-dip galvanizing deposits a thick, robust layer of zinc-iron alloys on the surface of a steel item. In the case of automobile bodies, where additional decorative coatings of paint will be applied, a thinner form of galvanizing is applied by electro-galvanizing. The hot-dip process generally does not reduce strength on a measurable scale, with the exception of high-strength steels where hydrogen embrittlement can become a problem. This is a consideration for the manufacture of wire rope and other highly stressed products. The protection provided by hot-dip galvanizing is insufficient for products that will be constantly exposed to corrosive materials such as acids. For these applications, more expensive stainless steel is preferred. Some nails made today are galvanized. Nonetheless, electroplating is used on its own for many outdoor applications because it is cheaper than hot-dip zinc coating and looks good when new. Another reason not to use hot-dip zinc coating is that for bolts and nuts size M10 are smaller, the thick hot-dipped coating fills in too much of the threads, which reduces strength. This means that for cars, bicycles, and many other light mechanical products, the alternative to electroplating bolts and nuts is not hot-dip zinc coating, but making the bolts and nuts from stainless steel. The size of crystallites in galvanized coatings is a visible and aesthetic feature, known as spangle, by varying the number of particles added for heterogeneous nucleation and the rate of cooling in a hot-dip process. The spangle can be adjusted from an apparently uniform surface to grains several centimeters wide. Visible crystallites are rare in other engineering materials. Thermal diffusion galvanizing, or Chaeranizing, provides a zinc diffusion coating on iron or copper-based materials. Parts and zinc powder are tumbled in a sealed rotating drum. Around 300 degrees Celsius, zinc will diffuse into the substrate to form a zinc alloy. The preparation of the goods can be carried out by shot blasting. The process is also known as dry galvanizing, because no liquids are involved. However, no danger of hydrogen embrittlement of the goods exists. The dull gray crystal structure of the zinc diffusion coating has a good adhesion to paint powder coatings. or rubber. It is a preferred method for coating small, complex-shaped metals, and for smoothing rough surfaces on items formed with powder metal. Eventual corrosion. Although galvanizing will inhibit attack of the underlying steel, rusting will be inevitable after some decades, especially if exposed to acidic conditions. For example, corrugated iron sheet roofing will start to degrade within a few years despite the protective action of the zinc coating. Marine and salty environments also lower the lifetime of galvanized iron because the high electrical conductivity of seawater increases the rate of corrosion primarily through converting the solid zinc to soluble zinc chloride, which simply washes away. Galvanized car frames exemplify this. They corrode much quicker in cold environments due to road salt, though they will last longer than unprotected steel. Galvanized steel can last for many decades if other means are maintained, such as paint coatings and additional sacrificial anodes. The rate of corrosion in non-salty environments is mainly due to levels of sulfur dioxide in the air. In the most benign natural environments, such as inland low-population areas, galvanized steel can last without rust for over 100 years. Galvanized piping. In the early 20th century, galvanized piping replaced cast iron and lead in cold water plumbing. Typically, galvanized piping rusts from the inside out, building up plaques on the inside of the piping, causing both water pressure problems and eventual pipe failure. These plaques can flake off, leading to visible impurities in water and a slightly metallic taste. The life expectancy of such piping is about 70 years, but it may vary by region due to impurities in the water supply and the proximity of electrical grids for which interior piping acts as a pathway. Pipe longevity also depends on the thickness of zinc in the original galvanizing, which ranges on a scale from G40 to G210, and whether the pipe was galvanized on both the inside and outside, or just the outside. Since World War II, copper and plastic piping have replaced galvanized piping for interior drinking water service, but galvanized steel pipes are still used in outdoor applications requiring steel's superior mechanical strength. This lends some truth to the urban myth that water purity in outdoor water faucets is lower, but the actual impurities are harmless. The presence of galvanized piping detracts from the appraised value of housing stock because piping can fail, increasing the risk of water damage. Galvanized piping will eventually need to be replaced if housing stock is to outlast a 50 to 70-year life expectancy, and some jurisdictions require galvanized piping to be replaced before sale. One option to extend the life expectancy of existing galvanized piping is to line it with an epoxy resin. Galvanized construction steel. This is the most common use for galvanizing, and hundreds of thousands of tons are galvanized annually worldwide. In developed countries, most larger cities have several galvanizing factories, and many items of steel manufacture are galvanized for protection. Typically these include street furniture, building frameworks, balconies, verandas, staircases, ladders, walkways and more.